So now let's take a look at the grocery store's problem. And in this particular problem, we notice that we don't have the fixed production rate. So the production rate will be unlimited. However, we have the back order. So this is an EOQ model with planned back order. So the first thing we want to do, again, write out everything we know. The demand will be 50 per day. And we also have the back order cost, we call it B, and it will be 50 cents. We also have holding cost, which will be 1 cent. The fixed order cost will be $10. The lead time is equal to 4 days. Okay? Then we can start to work on the problem. When you are trying to solve the EOQ with planned back order, the first thing you want to calculate will be the service level, the optimal service level, and we call it alpha. The formulation for alpha will be B divided by B plus H. So in this case, it will be 0.5 divided by 0.01 plus 0.5. I believe this is somewhere around 98%. Okay, so it means that when the customer arrives, 98% of the chance they will be able to get the item right away. Or put it differently, only 2% of the customer will experience stock out and they need to get the back orders. So once you have the service level calculated, the next thing we want to do is to calculate the optimal quantities. And it will be equal to square root of 2AD divided by H alpha. So we plug in all the number. 2 times 10 times 50 divided by H will be 0.01. Alpha will be 0.98. And I believe this is somewhere around 319.44. Okay. Then the next thing we can calculate will be what will be the back order level. And we call it SS star. And SS star formulation will be equal to negative 1 minus alpha times your optimal order quantities. In other words, it will be negative 0.02 times 319.44, roughly equal to 6.39, a negative one. So it means that your back order level will be 6.39 units, and you don't want to accept a back order that is higher than that. And so we have the optimal order quantity, we have the back order. Remember, we also have lead time. So we need to find out the reorder point. The formulation for the reorder point will be equal to demand rate times the lead time plus your back order level, because some of the unit will be delivered to the customer who did not get the item in the previous period, and that's why you need to consider that part. So we have 50 times 4 subtract by 6.39, and the answer will be 193.61. In other words, whenever your inventory level drop to 193 units, this is when you need to place the new orders. Now, let's say the grocery store decide to choose a different service level, and we don't want to use 98%, although 98% will be the optimal, but instead we want to set a different value. And suppose the owner decides to keep the service level at 80%. How can we find out the order quantity, back order level, and the reorder point? So suppose this is a goal, and we call it alpha 0. We want to keep alpha 0 equal to 80%. Then you can apply all the formulation we had for the previous setup. Instead of using alpha, you replace alpha by alpha 0. So the first thing, order quantity will be square root of 2 times A times D divided by H times alpha 0. Okay, so I have 2 times 10 times 50 divided by 0.01 multiplied by 0.8. And the answer would be 353.55. And for the back order level, you'll be -1 subtract by alpha 0 multiplied by your optimal order quantity. So I have -0.2 times 353.55. And the answer is -70.71. So as you can see, when the service level drops from 98% to 80%, we actually want to have a higher level of the backorder quantities. And for the reorder point, formulation will be DL plus SS star. So you'll be 50 times 10 minus 70.71. I believe this is equal to 129.289.